So if I say that there is a graph, a parabola, with the vertex at point 1, 3, and it also passes through the point 2, 6. And what we need to do is find an equation that represents this parabola. Now you might be thinking, well, how do we do that when we don't even have a picture of the graph? Well, let's think back to what we did in the last video. If we knew what the vertex was, we wrote out the equation for the vertex form of a parabola. And we know that the vertex is b comma c. So we can just substitute in x minus b of 1 squared plus c of 3. And then what we try to do is find a using the picture of the graph. Now, since we don't have a picture, we can't determine the steepness of the graph just by looking at it. So we're going to have to solve for it algebraically. So when we had to do that, we found another point on the graph, and we substituted the x and y coordinates of that point in. Well, we already have that point. It's right here. We're given that the graph passes through 2, 6. So we can just substitute that point right in here for x and y. So if y is 6 and x is 2, we just changed x to 2 and y to 6. And there we go. Now we just have to finish solving this equation. So here we're going to get a equals 6 minus 3. So a equals 3. And the equation, leaving x and y as they are, will be a of 3 times x minus b of 1 squared plus c of 3. And now we just want to go one step further and convert to standard form. So let's see if we can do this all in one step. This is going to be x squared minus 2x plus 1, so multiplied by 3 will be 3x squared minus 6x plus 3 plus another 3 will be plus 6. And there we go. All right, let's just do one more like that. Vertex of -2, -5, and passing through the point 2, -9. So we just write out the equation of the vertex form. And now we're going to substitute in y is -9, x is 2. Be careful not to confuse. X and y are this other point that we're given, and b and c is the vertex. So x minus -2 for b will be x plus 2 plus c of -5, so minus 5. And look, we just substituted everything in there at once, so now we just have to solve this. And we get a equal to -1/4. Substitute that in. So we're taking this equation, but changing, well, we're taking this equation and substituting in for a, b, and c. And we have b is -2, but since it's minus -2, it's plus 2 squared minus 5. Now we want to convert to standard form. Again, let's see if we can do this in one step. X squared plus 4x plus 4 will be, times negative 1/4 will be negative 1/4 x squared. 4x times negative 1/4 is minus x. And 4 times negative 1/4 is minus 1. Plus the minus 5 is minus 6. There we go. Okay, now let's change it up a bit. Now we're going to start given the two roots of the graph. The roots are at x values of 2 and negative 1. And then we're also given that the graph passes through negative 2, 16. So now, since we have the roots but not the vertex, we're going to use the equation for root form, which is a times x minus b times x minus c, where the roots are b and c. So what we're going to do is x and y we have right here, and b and c we have right here. So y of 16 equals a times x of negative 2. Remember, x and y are always the additional point we're given on the graph. Since that was the point, we're substituting the x, y values of that point into the equation, which is going to already have the roots in it. So x of negative 2 minus the first root of 2, and then x of negative 2 minus negative 1, so plus 1. And we simplify this out. We're going to get 4a equals 16. So a is 4. And so the final equation will be y equals 4 times x minus 2 times x minus negative 1, or x plus 1. In standard form, this is going to be 4 times x squared minus x minus 2. So 4x squared minus x times 4, so minus 4x, minus 2 times 4 is minus 8. Okay, now we're going to do a different kind of parabola. We're going to do a parabola that only has one root, and that one root is negative 4. And we know that it passes through negative 7, 3. So now, when we set up the root form equation, remember that this one root is a duplicate root. So even though on the graph it's only touching the x-axis once, it really means that there are two roots, negative 4 and negative 4. They're just laid right on top of each other. So the equation, let's do this all in one step. We have, at this point on the graph, we have y equals 3. X is negative 7. So minus negative 4 will be plus 4 for the first root. And then negative 7, again minus negative 4. It's the same value for the second root. It's a duplicate root. So again, plus 4. So negative 7 plus 4, we have that twice here. So this is going to be negative 3 times negative 3, or negative 3 squared. So we will get a equal to 1/3. So y equals a of 1/3 times x minus negative 4, x plus 4, times x plus 4. So since it's x plus 4 times x plus 4, it's x plus 4 squared. So this is, once again, the root form and the vertex form. So what you see is that we could have very easily done this problem using the vertex form, because remember that when you only have one root, it's touching the x-axis, which means that is where the graph starts from. So it is the vertex as well. We could have said the vertex was, as we can see, if we put a plus 0 there, the vertex is negative 4, 0. Substituted that into the vertex form equation, and we would have ended up with the same answer. And now if we want to put this into standard form, we'll get x squared plus 8x plus 16 times 1/3. So that's 1/3 x squared plus 8/3 x plus 16 over 3. We just multiplied that out and then multiplied each term, divided each term by 3. Okay, now we're going to do another one where you're only given one root. But this time I'm going to tell you that this is a parabola that does have two roots. I'm just not going to tell you what the other one is. Instead, I will give you the vertex. So we will have a vertex at this point, a root at that point, and another root that we don't know. So your first guess might be to try using the vertex form, since we know what the vertex is, but not what the two roots are. So if we tried the vertex form, so now your first guess might be to try the root form, since we know what one of the roots is, and we can use the vertex coordinates as another point on the graph. So if we tried using root form, if we just treat this as any other point on the graph, we could use the x, y values to substitute into here. Y of negative 2 equals a times x of negative 3 minus the root of 2, and then x minus, we don't know what the other root is, so we're going to leave that as c. So now we can put negative 3 in there. Okay, so now that we've done that, we are left with a and c, two different variables, but this is the only equation we have. So it's not possible to do this problem using root form. What we have to do is use vertex form. And that is because we already know exactly what the vertex is. We don't know what the two roots are. So we'll start with exactly what we know, what we already know all of, which is we know both coordinates of the vertex. So that's more information to work with. So we'll have y. Start over. Now we're going to do another problem where you're only given one root. But this time, I'm going to tell you that this parabola does have two roots. I'm just not going to tell you what the second one is. Instead, I will give you the vertex. Of negative 3, negative 2. So your first guess here, in order to write the equation, might be to use root form, since we know what one of the roots is, and we can treat the vertex as just any other point on the graph, x comma y. So if we use root form, then we have y of -2 equals a times x of -3 minus the first root of 2 times x of -3. And then we don't know what the second root is, so we're just going to leave that as c. Now here's the problem. We have one equation here, but two variables that we have to solve for, a and c. So that is not possible. So we can't use root form to solve this. Instead, we're going to have to use vertex form. And if you think about it, that makes sense because we have more information with that. We have the exact coordinates of the vertex, x and y. With the roots, we only have one out of the 2 points. So we'll start with what we know the most about. So now, the vertex is going to become what it is in the vertex formula, which is b comma c. And we're going, for the x and y coordinates, we're going to use this root. Remember, what is the y value for a root on the x-axis? It's 0. So the root of 2 is the point 2, 0. So now this is going to become our x and y. So now we have y of 0 equals a times x of 2 minus b of -3, so plus 3, and c of -2. So now we only have a that we need to solve for, so we can do that. So we're going to get 5 squared times a, that's 25a equals 2. A will equal 2 over 25. And so the final equation, 2 over 25 times x minus, now we never did figure out what the second root is, but that's okay because we're writing this in vertex form. We have b is -3, so x minus -3, that's going to be x plus 3 squared minus 2. Now we're going to do another one where you're only given one root, except this time I'm going to tell you that this parabola does have two roots. I'm just not going to tell you what the second one is. Okay, and what I will give you instead is the vertex. So your first guess here might be to say, well, we have a root, so let's use root form. So if we did that, we have a root, and then we would need an x and a y. So we could make this vertex just any other point on the graph that we would substitute the x and y values in for. So then we would have y of -2 equals a times x of 3 minus this root of 2, and then x of 3 minus, we don't know what the second root is, so we would just leave that as c. But that's where the problem is, because now we have an equation, one equation, but we have two variables. We have a and c. So there's no way to solve for two variables with one equation. So root form is not going to work. What will work is using vertex form, and that is because with vertex form, we already have the whole vertex. We have the x and y coordinate of the vertex, whereas with the roots, we only had one out of the two roots. We didn't have all the information we needed to use that form. So now that we're using vertex form, the x and y coordinates of the vertex become b and c. But now we need another point on the graph to use for x and y. It doesn't look like we have another point here, but we actually do, because remember, a root is just the x value of a point on the graph. It's the x value where the point is on the x-axis, and on the x-axis, y equals 0. So the root of 2 is the same as the point 2, 0. So now we will substitute in y of 0, x of 2, b of 3, and c of -2. And now we only have a as our variable, so we can solve that. So we will get this is a equals 2. So the equation in vertex form will be y equals a of 2 times x minus b of 3 squared minus plus a c of -2. In standard form, this is going to be 2 times x squared times 2 times -6, so minus 12x, plus 2 times 9, so plus 18, minus 2 will be plus 16. There we go. Okay, so in the next video, we are going to continue with these types of problems, except they will get harder.